Hi, my name is Megan McCormick, and in this video I'm going to discuss data management concepts. In this video I will be discussing the ETL process, how to use optimal techniques for querying data. I will also discuss business intelligence, cloud data storage, and also how to automate SSIS packages and stored procedures. So first things first, we need to import our data to work with for the discussion of these topics. One way to do that is to bring in a flat file and import it into a database using the import-export tool. Here is an example of what that looks like. You have the flat file source. You can then look at the columns that are in the data source, use the advanced option to map the data set, and then preview it to make sure that everything looks good. Further, in this process, you define the destination, which data table you'd use, etc., etc. From there, you can take that denormalized data and use a stored procedure to populate your normalized schema. Here's an example of a stored procedure that uses the distinct keyword in order to make sure that the data is unique. Further, you can ensure the integrity by checking it using a select statement to ensure that your foreign keys and your primary keys ensure that entity integrity and that domain integrity. Entity integrity makes sure that your relationships that are set from many to many, or one to one, one to many, are good, for lack of a better term. And you want to make sure that your domain integrity, that the columns that you're bringing in are being saved and not getting truncated. Once we have our data into the database, there are several optimal techniques for querying the data. First off, we can focus on the join order. So we can start with, if we want to use a join, we'd start with the smallest table in that join. That way, that join table gets put into memory, and each time it's called, the memory is already there. First, we can limit the amount of subqueries that we're using. Subqueries are great if we want to try to use them like in a where clause, and we can filter data using another one. Another table. However, we can also use the join, which would put it in memory and make the query faster. Similarly, we can also use partitioning. Partitioning chunks up the data into easier to process bytes. This also allows for parallel processing, which makes querying that much faster. We can also create indexes. There are two types, clustered and non-clustered. Non-clustered doesn't use the order by key, so how the data is presented is how it is stored in the index. The clustered index would sort the data by the key. So it really depends on what you want to do with your query to determine what index you want to use. Lastly, we can also look at the execution plan to make sure that the execution plan that we're using is the most optimal one. The query processor doesn't always pick the most optimal one, so we can use hints to make the processing that much faster. Now that we have our data in the database, I want to discuss the ETL process. The ETL process stands for extract, transform, and load, and what it is good for is cleaning up data and creating a process that cleans up data from either raw imports, other databases, and puts it into our database for easier access. First, the extract in the ETL process is it takes the raw data and imports the data into the database. Typically, this involves just taking the data from various raw files and other databases and putting it into an extract schema. From there, you transform the data, and you can use this doing a stored procedure or an SSIS package. Here, I am showing an SSIS package version of the ETL process. However, as you can see in both of these, they're executing a stored procedure to clean up the data to make it more functional for the application that is using this data. Once the data has been cleaned in the transform process, it then goes to the load. And the load essentially just makes sure that the data is ready to go in a production environment, or just ready to go in an environment that is consuming the data and is being used. From there, we can talk about automating data movement. We can take this ETL process and put it on a timer, so to speak, so that it runs at a certain point in the day, every day of the week, or we can have it run weekly or monthly. To do this, we'd use the SQL Server agent to configure a job. From there, we get a job step, which is shown in this screenshot right here. The job step, so in this one, it's executing the master SSIS package. We'd take that, we would set it up, make sure that it's executing correctly, and then we can then from there schedule it. As you can see in this screenshot, we are scheduling well, we're not scheduling actually, but you can schedule it to run at a certain point in the day. And from here, you could um, email, so you could set up the database mail, which alerts the user or whoever is like the DBA or whatnot when the job succeeds or when the job fails, or if something were to error out. This is good because if something were to happen and you were on a weekend shift, you would know that a process was failed or successful and you wouldn't have to worry about it. I now want to talk about business intelligence. Business intelligence typically uses OLAP, or online analytic processing, which usually involves dimensional modeling. What I've been discussing so far has largely related to like a normalized database using a typical online transaction processing model. Right now I want to talk about dimensional modeling, which uses star schema and snowflake schemas, which have fact and dimension tables. Fact and dimension tables describe the data that we're dealing with, and fact tables are really the grouped data together along with aggregate data. This helps us analyze the data that we have in order to make visualizations. One thing I want to discuss is how to make a visualization in Microsoft Power BI. We can do this in Microsoft Power BI by taking the data and putting them into graphs and having that data readily available in a visual form. This makes the data much easier to understand and a lot easier to grasp, especially if you have a very large data set. Since this data is static, I want to show you the real report. So here's the real report. One thing that is really cool about these visualizations is you can click on a graph and it will show you where that data is coming from. So I just clicked on Wisconsin, and as you can see, here are the total number of incidences by year. So in 2015, there were 11 wildlife aircraft strikes and 45 total incidences as a whole in the last 15 years involving aircraft and wildlife for Delta Airlines. Here are the top 10 airports by the number of incidences. And what's great about this is that business people can then use this data to make decisions. That's really cool because if you just got a raw data file, you might not know what's in it. This helps organize and present that data so that decisions can be made. So the last topic I want to discuss is cloud-based data architecture. One of the great things about cloud-based data storage is that you don't have to have a server and the people required to maintain that server. It allows for easy scalability. So if your data set gets bigger, you can just click a few things and the amount of storage you have expands. Further, it's competitive pricing, especially compared to a private server. That private server, the cost to maintain also involves electricity bills, air conditioning bills, and it also involves somebody being able to maintain that server. So having the ability to have that server being maintained by somebody else and not on site, it really reduces the overhead cost of having a server. So that makes it a lot easier to just scale. It makes it easier to security because you have experts looking over the data in a cloud-based data storage set. Further, some of the things I personally have done is I've converted a database into MySQL to store it into the Google Cloud Storage, which takes MySQL files and then puts them there so that they're easy to query. You can also create a data set on your own using Google Cloud, and you can just store files and whatnot, and it's a lot easier to do it through there than having it on your own personal server. Here's a screenshot of the querying used in the Google Cloud Storage. As you can see, the Google query language is very similar to a MySQL or even t-sql. The only difference I think is limit 1000 versus top 1000. And as you can see, it's bringing data back from that aircraft wildlife strike data warehouse that was created for the Microsoft Business Intelligence. So yeah, that's all I have to discuss about data management concepts. Thank you for watching, and I hope you learned something.